Here is 101 fascinating facts about black hole. Black holes aren't holes at all. They're regions of space where gravity is so intense that nothing, not even light, can escape. But what's most disturbing is that we don't truly know what lies beyond the event horizon. It's a one-way trapdoor to an unknowable realm. The center of a black hole, known as the singularity, is a point where all known laws of physics break down. Space, time, mass, and gravity all collapse into infinity. It's not just strange, it's literally beyond human comprehension, like a glitch in the fabric of existence. Some black holes spin so fast that they drag space and time around them like water swirling down a drain. This effect, called frame dragging, can warp nearby objects' paths, and in theory, it could allow for bizarre phenomena like time loops or closed time-like curves. Supermassive black holes can weigh billions of times more than our Sun. The one in the center of the galaxy, M87, is so large that it could swallow our entire solar system. Yet it hides in plain sight, veiled by darkness, devouring matter for eons. If you fell into a stellar mass black hole feet first, you'd experience spaghettification, your body stretched into a long, thin strand by tidal forces. The difference in gravity from your head to your feet would become so extreme that your atoms would be pulled apart. Black holes can collide. When they do, they merge into an even larger black hole and release gravitational waves, ripples in space-time, that travel across the universe. These events are so powerful, they briefly release more energy than all the stars in the observable universe combined. Black holes can evaporate over time via Hawking radiation, a theoretical process where particles escape from the event horizon. But for most black holes, this would take longer than the current age of the universe. In the end, they may simply fizzle out in a puff of quantum nothingness. There are wandering black holes, rogue cosmic monsters ejected from galaxies due to gravitational slingshots or collisions. These lone black holes drift invisibly through interstellar space. One could pass through our solar system unseen, and we wouldn't know until it began devouring planets. Some theories suggest that black holes could be gateways to other universes or regions of space-time. If so, what falls in may emerge somewhere else or someone else. But we have no evidence and no way to test it. It remains a mind-bending speculation. You might think the event horizon is a sharp border, but it's more like a no-return threshold. What's horrifying is that from your own point of view, you might not even notice the exact moment you cross it, until escape becomes absolutely impossible. Supermassive black holes are not rare. They're found in the centers of most large galaxies, including our own. Our galaxy's central black hole, Sagittarius A*, is quiet now, but evidence suggests it has violently erupted in the past, potentially sterilizing parts of the Milky Way. Black holes don't suck like vacuums. They bend space-time. If our sun were replaced by a black hole of equal mass, Earth's orbit wouldn't change at all. It's not the suction that's dangerous, it's what happens if you get too close to the edge. Infalling material around black holes forms an accretion disk that can glow brighter than entire galaxies. This isn't from the black hole itself, but from matter heated to billions of degrees as it's ripped apart. The brightest objects in the universe are fueled by complete destruction. Some scientists speculate that the universe itself may have originated from a black hole. If so, our Big Bang could be the result of matter collapsing in another universe's singularity, meaning every black hole might spawn a new cosmos in an eternal cycle of creation and collapse. We used to think nothing could escape a black hole, but Stephen Hawking showed that they might emit radiation due to quantum effects. This discovery led to the infamous information paradox. If black holes evaporate, where does all the information they swallowed go? The mass of a black hole determines the size of its event horizon. Double the mass, double the radius. But volume increases even faster, meaning a black hole with 1 billion times the sun's mass could be larger than the orbit of Pluto, yet equally dense. Some tiny black holes may have formed just after the Big Bang, called primordial black holes. These could be as small as an atom, but more massive than a mountain. If they exist, They could be everywhere. Some theorists even believe they could account for dark matter. Black holes distort time. The closer you get to one, the slower time moves relative to an outside observer. If you hover just above the event horizon for a few minutes and return, you might find that years, or even centuries, had passed for everyone else. There are theories suggesting black holes might preserve the information they swallow on a 2D surface at their boundary, an idea called the holographic principle. If true, everything you ever were could be stored as a pattern on the edge of a cosmic abyss. Black holes can spin at nearly the speed of light. The faster they spin, the more they flatten into oblate shapes, and the closer matter can orbit before plunging in. This rapid rotation twists space around them, generating incredibly complex and extreme physical environments. The edge of a spinning black hole, the ergosphere, allows for a bizarre possibility: energy extraction. According to the Penrose process, particles entering this region can split, with one falling in and the other escaping with more energy than it entered. Theoretically, this could power civilizations or weapons of unfathomable magnitude. When a star dies in a supernova and collapses into a black hole, the actual process takes just seconds. In that moment, a mass greater than the sun collapses into a point smaller than a proton, creating a gravitational monster born from sudden cosmic violence and infinite density. If you tried to watch someone fall into a black hole, you never see them cross the event horizon. Due to time dilation, they'd appear to slow down and freeze, fading into red and eventually vanishing from sight as their image was stretched across time. Black holes might play a role in galaxy formation. Evidence suggests that supermassive black holes regulate star birth by blasting powerful jets of radiation and matter, essentially cooking or compressing surrounding gas, either triggering new stars or halting their formation altogether. Black holes don't just feed, they burn. After devouring massive amounts of matter, some eject powerful relativistic jets of particles thousands of light years long. These jets are so massive they can pierce through galaxies and affect star formation millions of light years away. At the heart of some of the largest black holes, the gravity is so intense that it can pull in entire stars. If a star strays too close, it's shredded in a process called a tidal disruption event. Its guts ripped into an accretion disk of glowing debris. The most massive black hole ever discovered, TON 618, has a mass over 66 billion times that of our Sun. It's so huge it defies current astrophysical models, and its event horizon is larger than our entire solar system, a truly cosmic god-devouring entity. Some black holes are part of binary systems, orbiting normal stars. These X-ray binaries emit powerful radiation as the black hole feeds on its companion star. This cannibalism continues until the star is entirely consumed or escapes, a horrifying cosmic relationship with a fatal end. If a black hole forms near Earth, however unlikely, it could destabilize our planet's orbit or worse, begin pulling matter directly from our world. While extremely rare, the consequences would be absolute. No escape, no warning, no defense against gravity itself going rogue. Quantum mechanics suggests black holes can become entangled with particles outside the event horizon, leading to the black hole firewall paradox. If true, it may mean that instead of smoothly falling in, anything crossing the boundary is incinerated instantly, a violent death instead of a silent plunge. When gravitational waves from merging black holes are detected on Earth, we are literally being jiggled, ever so slightly, by an event that happened billions of years ago, billions of light years away. Earth is still echoing from ancient deaths of invisible giants. Black holes distort the fabric of space so dramatically that they can act like lenses. This gravitational lensing allows them to bend and magnify the light of objects behind them, sometimes creating rings or arcs of warped galaxies millions of light years beyond. Black holes can spin so fast they reach a theoretical limit called the Kerr limit. If they spin any faster, they would expose their singularity to the universe, violating cosmic censorship. Such a naked singularity would break physics as we know it. The no-hair theorem states that a black hole has only three observable properties: mass, charge, and spin. That means all other information about what fell in, how, when, or why is lost. In essence, a million stars or a single book look identical once swallowed. There are black holes so small they might exist at the atomic scale, called micro black holes. If one passed through Earth, it might not even slow down. It could pass through people, buildings, or the planet itself, creating imperceptible distortions as it vanished into space. In simulations, the merger of two spinning black holes can recoil with such force that the final object is flung out of its galaxy at thousands of kilometers per second. These recoiling black holes are cosmic exiles, moving between galaxies like interstellar fugitives. In the distant future, black holes may be all that remains. Stars will die, planets will freeze, and galaxies will fade. Black holes will dominate the universe, gradually evaporating until even they vanish, leaving behind an empty, cold void called the heat death of the cosmos. Black holes aren't invincible. In theories involving hypothetical particles like axions or scalar fields, black holes could be destabilized or lose mass rapidly. Though entirely theoretical, such ideas suggest black holes might be more dynamic and destructible than previously imagined. When falling into a rotating black hole, you wouldn't go straight to the singularity. The rotation might allow you to spiral inward and avoid it, at least temporarily. In theory, this could create a shortcut through space-time, but at the cost of extreme gravitational stress. There's a class of ultramassive black holes theorized to be in the centers of giant elliptical galaxies. These monsters could weigh more than 100 billion suns and influence galactic structures hundreds of thousands of light years across, acting as anchors for galaxy clusters and dark matter webs. Some black holes are known as quasars when actively feeding. Quasars emit so much energy they can outshine entire galaxies. Powered by matter spiraling into a supermassive black hole, these bright beacons are visible across billions of light years, lighting up the otherwise invisible darkness. You might assume that a black hole would be pitch black, but that's only true for the singularity. The area around it can glow with X-rays, gamma rays, and high-energy light from matter being violently shredded, creating some of the brightest spots in the known universe. There may be a black hole just 1,500 light-years from Earth inside the constellation Ophiuchus. It's invisible, detected only by how it affects nearby stars. These dark companions could be much closer than we imagine, hiding in the darkness, undetected and silent. The event horizon isn't a surface, it's a boundary in space-time. Cross it, and even light cannot escape. There's no wall, no fire, no visible edge. But once you're past it, escape requires exceeding the speed of light, an impossible demand that seals your fate. In 2019, the Event Horizon Telescope captured the first direct image of a black hole shadow. The blurry, glowing ring surrounding the void was a century in the making, a triumph of collaboration and precision that revealed the face of one of the universe's deadliest objects. Black holes are thermodynamically hot. Despite being the coldest places in the universe by temperature, their entropy is immense, greater than 1 billion suns. This thermodynamic paradox has forced physicists to reevaluate how entropy, information, and gravity work at cosmic and quantum scales. When black holes spin, they generate enormous magnetic fields that twist and loop into colossal structures. These fields help form relativistic jets that launch matter at nearly the speed of light, tearing through galaxies like cosmic lances made of pure electromagnetic violence. Black holes may not be eternal prisons. Some theories propose that information falling into a black hole is imprinted on the event horizon, possibly allowing it to be re-emitted as Hawking radiation, a radical idea that suggests destruction may not be truly final. The largest black holes reside in giant elliptical galaxies in the centers of galaxy clusters. These cosmic overlords anchor vast webs of dark matter, influence the flow of intergalactic gas, and can shut down entire galaxy star formation through their feedback mechanisms. If a black hole were to pass through a molecular cloud, it could trigger star formation. Its gravity compresses the gas, creating new suns. So while it's a force of destruction, They might paradoxically sow the seeds for future solar systems and life. Time near a black hole moves so slowly that in some cases, millions of years might pass in the universe while mere hours elapse for someone near the event horizon. This relativistic effect has inspired numerous science fiction plots, and it's completely real. Even the concept of inside black hole is fuzzy. Once you pass the event horizon, directions lose meaning. Space and time reverse roles. Time becomes a direction you must move in, and space becomes an unavoidable destination pulling you toward your end. The Milky Way's supermassive black hole, Sagittarius A*, flared suddenly in the 1990s, emitting radiation that lit up nearby gas clouds 26,000 light-years away. Scientists believe it may have devoured a planet or asteroid in a sudden, violent feeding frenzy. The gravitational field of a black hole can stretch starlight into strange colors and shapes. Stars orbiting near a black hole appear distorted or multiplied due to gravitational lensing, like a cosmic funhouse mirror created by the curvature of space-time itself. If you could survive falling into a black hole, your perspective would remain normal. You'd feel acceleration, but nothing dramatic at the horizon. But to the outside universe, you'd seem to freeze and fade forever, your light redshifted until it disappears entirely. Black holes can create photon spheres, regions where light orbits the black hole endlessly. If you entered one, you'd see your own back, the front of your head, and infinite repetitions of the universe looping around you like a hall of mirrors in space-time. Some researchers believe that black holes might not have singularities at all. Instead, the core may be a Planck star, a quantum object where space-time bounces instead of collapsing. If true, black holes wouldn't destroy matter, but convert it into strange, compressed geometry. The deepest known gravitational well in the universe exists inside a black hole. This is the lowest point energy can sink to, where escape requires infinite energy. It's not just a trap, it's the ultimate gravitational abyss, deeper than any cosmic pit imaginable. In simulations, black holes colliding at high speed don't just merge, they can splash space-time, creating gravitational wave echoes. These ripples reveal the structure of space itself and give scientists clues about how black holes respond to violent distortions. Though black holes are terrifying, they may have saved the universe. By regulating galactic activity, their jets and radiation may have prevented runaway star formation. Without them, galaxies might have collapsed into chaotic starburst zones, incapable of sustaining complex planetary systems like ours. Some supermassive black holes don't just sit at the center of galaxies, they move. If a galaxy merges with another, their central black holes spiral around each other, forming binary systems. These titanic pairs will eventually merge, shaking the universe with gravitational shockwaves when they collide. In 2021, scientists found what appeared to be a wandering supermassive black hole, leaving a trail of newborn stars behind it. This rogue black hole might be flying through space at millions of kilometers per hour, literally triggering star birth as it goes, like a cosmic lawn sprinkler. Black holes can bend light from behind them in such a perfect way that the image loops around, creating something called an Einstein ring. When viewed just right, the gravitational lensing can produce a perfect circle of duplicated starlight around the invisible object. Theoretically, if you orbit a rotating black hole just right, you can stay in motion indefinitely without using fuel. This is known as the black hole battery effect. However, the required conditions are so specific that any deviation would result in being ripped apart. There is no known material that could survive direct contact with a black hole's event horizon. No metal, no shield, no futuristic alloy. Once something crosses the threshold, its atoms are doomed to spiral inward toward annihilation in the singularity. The rotation of some black holes is so extreme they drag time itself into loops. In theory, near such an object, you could return to a previous moment, creating potential time travel paradoxes that Einstein's equations predict but reality may not permit. In some scenarios, black holes formed from the collapse of stars can be surrounded by a remnant neutron star crust. These quark matter halos could persist briefly around the black hole, containing ultra-dense material just outside the event horizon, like an atomic shell clinging to a gravitational ghost. Some black holes grow faster than expected. These super Eddington accretors consume gas and dust at rates that defy physics, hinting at unknown forces or processes at work. Scientists still don't fully understand how they break the rules of accretion and grow so rapidly. In rare cases, black holes can be born spinning at nearly their maximum possible rate, just shy of tearing space-time apart. These extremal black holes push the edge of physics, and if they exist, they may offer insight into quantum gravity and string theory. It's possible that black holes store the information they consume in the quantum fluctuations of their surface. This concept, known as soft hair, is one possible solution to the information paradox, but it remains deeply controversial and unproven, dividing physicists to this day. There may be black holes inside other black holes. If the internal structure of space-time allows for it, nested event horizons could form, fractal layers of gravitational collapse, each with its own internal geometry and physics. If true, we're only seeing the outermost layer of something far more complex. Some scientists think that the universe's dark energy, the mysterious force driving cosmic acceleration, might be linked to black holes. A radical idea suggests that the mass loss from black holes via Hawking radiation might subtly influence the rate of universal expansion over time. Black holes may serve as cosmic erasers. If two quantum entangled particles are separated and one falls into a black hole, the entanglement link is broken. This seemingly small effect could challenge fundamental ideas about causality and the limits of quantum communication. Some astronomers believe intermediate mass black holes, between stellar and supermassive sizes, may be hiding inside dense star clusters. These missing links could be the seeds of future galaxy-sized monsters, lurking in silence and waiting to grow by devouring stars in their neighborhoods. The physics of black holes is so extreme that some equations lead to imaginary numbers or infinite values. These naked infinities suggest our understanding of space-time is incomplete, requiring a deeper theory, perhaps quantum gravity or a unification of all known forces. The loudest sound in the universe may come from a black hole. Pressure waves from one supermassive black hole in the Perseus cluster produce a tone equivalent to a B-flat 57 octaves below middle C. It's a note so deep it takes millions of years to complete one cycle. If Earth were compressed into a black hole, its radius would be less than a centimeter. That means the entire mass of our planet would fit inside a marble-sized singularity, with gravitational pull strong enough to trap light and twist time around it. Black holes may not form immediately after a massive star dies. Some simulations show that matter can pause during collapse, creating a temporary neutron star-like object that exists for milliseconds before suddenly giving way to a black hole, a gravitational guillotine that falls without warning. In the extreme environments around black holes, quantum fluctuations may become amplified, potentially creating virtual particles that momentarily exist and annihilate one another. This may drive Hawking radiation, suggesting black holes don't just consume reality. They churn it, twist it, and occasionally spew it back out. While no light escapes a black hole, sound vibrations in surrounding matter can still echo through the accretion disk. Simulations show matter howling in spirals as it's torn apart, producing waves and tremors that ripple outward like screams from the edge of oblivion. Black holes don't just affect nearby objects, they warp the very geometry of the universe. Light paths curve, distances stretch, and straight lines no longer exist near their gravitational fields. This means space near a black hole is fundamentally different from the space we know. The earliest black holes may have formed just 100 million years after the Big Bang, too quickly for current models to explain. These ancient giants challenge our understanding of early galaxy formation and suggest unknown forces or massive seed black holes from primordial physics. Even though black holes are invisible, they leave visible scars in the form of distorted light, shredded stars, and gravitational wave echoes. Their presence is known only by their chaos, evidence that something unfathomable and predatory is hiding behind the curtain of space. The tidal forces near a black hole are so intense they can stretch not just matter, but even quantum fields. Some physicists believe the fundamental constants of nature could behave differently inside or near a singularity, making black holes laboratories for rewriting physical laws. Some black holes are dormant, completely undetectable unless they're feeding. That means countless invisible black holes may be drifting through space right now, undisturbed and undetectable, waiting for something to fall into their gravity well and trigger their monstrous awakening. When two black holes merge, they don't just form one larger black hole. They also recoil from the collision like a cosmic shotgun blast. This recoil can be so extreme that the resulting black hole is ejected from its galaxy entirely, a lonely titan hurled into the void. Some simulations suggest a strange possibility that a black hole could be created artificially in high-energy environments, such as future particle accelerators. While these would be microscopic and likely harmless, the idea that humans could manufacture space-time collapse is both thrilling and terrifying. If you encoded an entire human being into binary data and beamed it into a black hole, you would violate the laws of quantum mechanics. Black holes are information blackouts, and the moment that data crosses the event horizon, it seemingly ceases to exist. Theoretically, an object approaching the event horizon of a black hole can never be observed crossing it. Time dilation stretches the moment infinitely, so from an outside perspective, the object simply freezes in time, slowly fading into darkness as its clock stops ticking. Black holes don't grow in silence. Their feeding frenzies release bursts of radiation so powerful they can sterilize entire star systems. If Earth were too close to an active galactic nucleus, we'd be bombarded with deadly X-rays and gamma rays with nowhere to hide. One of the most chilling facts is that we may never truly understand black holes. They're the product of the most successful theories in physics, yet they simultaneously break those same theories. They are real, and yet they defy everything we think we know. Some black holes rotate so fast and carry such intense charge that they may act like massive particle accelerators. Particles trapped in their magnetospheres could be flung to near-light speeds, creating natural environments far more energetic than anything humanity has ever built. Black holes can trap gravitational waves, creating echoes that ring through space-time long after a merger. These subtle reverberations might someday allow us to hear the structure of the event horizon, unlocking a new type of observational science, black hole seismology. There may be millions of small, quiet black holes in the Milky Way, remnants of ancient stars. These stellar ghosts silently orbit the galaxy, invisible unless they interact with something. One could be drifting toward us right now, undetected, until the effects become unavoidable. The entropy of a black hole is proportional to the surface area of its event horizon, not its volume. This upside-down relationship suggests a deep connection between gravity, information, and geometry, and possibly a hint that reality itself may be fundamentally holographic. Black holes influence galactic behavior across vast distances. Their gravitational pole shapes star orbits tens of thousands of light years away. In a way, the galaxy dances to their tune, its spiral arms swirling under the influence of an invisible maestro at the core. One recent theory suggests that black holes might not be singularities at all, but fuzzballs, dense clouds of strings as predicted by string theory. If correct, this changes everything. Black holes wouldn't have a sharp edge or central point, but will be seething with quantum activity. Some galaxies don't just contain one black hole. They host pairs or even triples. These black hole clusters can create chaotic gravitational interactions that eject one black hole at relativistic speeds, creating intergalactic escapees never to return home. The death of a black hole via Hawking radiation would end in a final burst of energy, a black hole explosion. Though no such event has been observed, this terminal flare would release intense gamma rays and possibly leave behind a remnant, a stable object with unknown properties. Even our Sun may eventually contribute to black hole formation, not directly, but when the Milky Way merges with Andromeda, collisions between massive stars could trigger waves of black hole births. In the distant future, our galaxy will be littered with new cosmic beasts. If you could hover just above the event horizon of a supermassive black hole, you'd see the entire universe compressed into a single ring of light behind you, past, present, and future all warped and bent together in a circle of cosmic time.